Good day, lovely people. Today let's look at calculus and how to determine the area of the graph or area of the region enclosed by two graphs. We are given the graph of f of x, 1 minus x squared, and the graph of g of x, negative 4x plus 4. So the first thing we do is to sketch the graph to understand what we are going to calculate or the area we're going to determine. Having this, if we look at this graph, my y-intercept says make x 0. If I make x 0, I have 1 minus 0. So my y-intercept is at 0. If I make y 0, I have plus or minus 1. So this is the graph that this will generate, a negative graph. Then on the other one, my y-intercept is at 4. And my x-intercept, if I make y 0, my x-intercept will be, I'll have negative 4 equals negative 4x. My x-intercept will be at 1. My x-intercept will be at 1. So this is the graph that I'm going to have. So if they are asking for the area enclosed by these two graphs, it means they're asking for this area. This small shaded area, that is the only area they enclose. But now look at this. Look at this region. It doesn't have any specific basic shape. So it's not a triangle, it's not a rectangle, it's not a circle. We don't have any basic formula. So the only way we can calculate for the area of such shapes under calculus is to use integration. For integration, we need to check the intervals. And then we use definite integral to get the area. Now, let's go to this. How do we get the intervals? The intervals represent the point of intersection between the two graphs. So at the point of intersection, remember f of x must be equal to g of x. So what do? Equate the two equations. Negative 4x plus this. If we write this in standard form, we have x squared minus 4x, and we have 4 minus 1 is 3 equals to 0. We now factorize. So this will give us x minus 3 and x minus 1. Minus 3 minus 1 is 4. Minus 3 times minus 1 is 3. So the values are 3 and 1. So the intervals. So this, if we extend this line, it means it's going to be somewhere here, the point of intersection. So let's extend this graph. Remember, this graph here was drawn. It wasn't drawn to scale because I don't have a grid book. So this means the point of intersection will be around 3. And this is the enclosed area for the two of them. Now what do? We go into integration. And we use the graph on top minus the graph below. So in this case, it's going to be definite integral of this function, f of x, the one on top minus the one below. So it's going to be definite integral of f of x minus g of x. Now f of x is 1 minus x squared minus g of x, which is minus 4x plus 4. If we simplify that, let's simplify that. Definite integral from 1 to 3 of this is 1 minus 4 is minus 3. So let's start negative x squared. Negative is plus 4x. Then 1 minus 4 is minus 3. So we will look for the definite integral of this function from interval of 1 to 3. And that will give us the area of that enclosed region. So what do? Let's integrate. So the integral of this will be negative x, 2 plus 1 over 2 plus 1, which is 3, plus 4 into x 2 plus 1 plus 1 is 2 all over 2 minus. Remember that the integral of a constant is that constant x. But the one is for the interval of 1 to 3. For the interval of 1 to 3. Now let's plug it and get our area. If when x is 3, we have x cubed, we have negative of this 3 cubed all over 3 plus 4 divided by 2 is 2, so we have 2 into 3 all squared minus 3 times 3. That is the first interval, the upper one minus the lower one. The lower one will give us negative of 1 to the power of 3 all over 3 plus 2 times 1 all squared minus 3 times 1.